Okay. So I'm thinking for now, I'm not going to bother doing too much like module organizing. I'll do that later. But yeah. Okay, I think I'm gonna copy this. What? Sorry. I'm sorry, just... There we go. Okay, and unit, how is unit represented? Oh. Okay, I'm gonna have to look at these. Oh, I think I know what this is. This, okay. These are helpers for, yeah, currying and stuff. Yep. Right. Okay, these are helpful. Yeah. Yeah, cool. Unit, okay, so unit is just void. Okay. That's, I mean, that's fine. Okay, we'll get back to that. Okay, so unit, yeah. So void means it's a value that is not printed out. I don't know. I don't think I'll. How would I? No. Oops. I think I'd represent it just as the empty list. Maybe that's stupid. Actually, you know what? Let's do void. Now void makes perfect sense actually, because there are lots of procedures in Scheme that return void as like a nothing, and that's what you think of with unit in PureScript. Okay, so we have unit. Cool. Let's look at the IO monad. So so what I'm thinking about regards to the IO monad is I want to try something. I want to try. Okay, I realize now why I should have organized everything. I mean, yeah, okay, because it's easier to read. Okay. All right. So saying it's a functor. So here's what I'm thinking. There are a few interesting questions. One is like I don't think I will try and solve this, but I just want to bring it up at the IO is technically not. It's just it's a type system thing, and unless you want to do do like this and then have some effect on the other side, without it being executed, then IO has like no computational content. So there is like a question of like, wouldn't you want to like sort of optimize away a bunch of binds? What I'll do is I'll copy these, I think, and I think we need all of these. Oh, sorry. Right, this is so that you can do and just like have effect. That's what discard does. Okay, so we'll save these. Now we don't have, yeah, exactly, we need these. Let's just save these. I think I'll probably will actually make, oh, right. Oh, class functor. Oh yeah, of course. Here we go. Sure. Why not? Okay. Now, yeah, these don't exist here. Yeah, well, we'll pull this out into like its own effect module actually. Let's just try and make this work first. Okay. Bind. Okay. And let's think here. Yeah. Okay. Sure. What I wanna look into is doing like a parameterized effect type, like an indexed or something. It would be interesting. I want to look into it. I want to see it, and if there are like at least two types of indexed effects. One is like these effects can happen. I guess you could say there are three types. One is like what this type is in PureScript, and then you have like the old F, which had like, I think it had like something like you could sort of list out what types of effects were allowed. There's a third type where you have like a requirement. So like, I don't know. Actually, you could have like something along these lines, and then so here, I guess I'll name it end. So end can only be invoked if start has been invoked before. But then, and then there's like a question of like, okay, how, and then this would be like, question is, and I think it's possible, and we'll look into that. Like, how do you can you claim start is not in that row? I think it's possible. I think, and I'm gonna give it a shot. See, but if it's like I don't know, like you get atrocious error messages and stuff like that. Like compilers, I'm just I'll drop it, and I'll settle for like this type of effect, where it's just like you just list things that are allowed, and if that is too annoying, we'll just go with this. But I think it's fine. And okay, so let's bring these in. So we have IOMap, IOApply, IOPure, IOBind. Okay, let's pull these in, and let's put them. You know what? Let's put them here. There we go. And now they need to be in here. And let's see, what did I do with these? Oh yeah, they're just represented as lambdas, same as in JavaScript backend. Sorry, am I missing one? No. So is that it? Yeah, just 4 of them. Okay. IPure map. But the macro for the define IO procedure really good, because it's like helps you in Scheme to avoid making mistakes. Whoops. So yeah, so this actually, you know what? Let's just bring this in, because like this will curry and do everything. It just becomes much easier to work with. Define IO procedure. Let's see here. Yeah. So it's like, it's yeah, it just wraps it. IO procedure. Right. Yeah, because it takes the first, so it curries. Yeah. Okay. And this is just define name, and then does it do anything else? No. Okay, cool. Let's just bring this thing in here. Let's put it here. There we go. And we'll do, let's see here. Okay, no. Okay, yeah. IO procedure. There we go. Don't need these. Cool. Yeah. Let's just make this, let's format it so it reads a little bit easy to read. There we go. Cool. I don't know if I'm being silly, but okay, there we go. Great. Okay, so now we have these. And so I think actually right now, I think that we should be able to do something like, so now it says foreign import. Let's change things up a little bit. Let's do hello world. Import prelude, and I want oops, IO unit. Let's do, oops. Actually, let's do this. String IO unit. And let's just, oops. There we go. Main, and let's just, there we go. Hello. Cool. This returns, oops, hello. Cool. Cool. Nice. Yeah. And now in here, app, this is an effect, so you run it with this, and let's see here. Actually, I think that's it. Actually, what are we getting? Some issues here. Prelude was not found. No. Oh. There we go. Cool. And we run it. Okay. Embedded syntax. Define IO pure. Oh, yeah, this is incorrect. Let's see here. It's yeah. Okay. Cool. All right. Let's see how do we do this. Let's see if we can do this in a clever way. Here we go, and now run, and hello world. Awesome. Exception, attempt to apply non-procedure. Void, ooh, oops. What are we doing? We're doing something wrong. Oh, right. This is not, yeah. This needs to return a lambda. So, okay, so in order to avoid these mistakes, let's, there we go. Okay, let's think here. Can we, okay, let's see. Okay, so one approach is we have, okay, yeah, that's, okay, that is one approach. Okay, let's see, let's just do this. See, in a sense, it should belong in prim, but let's do this. We need like a common utilities for, we need utilities like macro utilities. Okay, let's just do utils for now, and ChezScheme. Okay, and then what we do is, let's see if we can't, so this thing works now, that's good. Let's see if we can take this thing here, And we put it oh, there we go. Boink. Okay. So we got this macro. Now what we can do is we can start. Okay, so we can import utils. And we'll do. There we go. We no longer need. There we go. Now we got an IO procedure, but it's no longer in here, so we can import. And let's see, this will work because when we run, okay, so we can access libraries in here. We'll see if about organizing this a little bit better, but let's, oops. It builds fine and runs fine. Cool. Yeah, okay. Let's, this stuff I hate, it's like naming, but let's go, I don't know. Scheme, macros? No, it's not just macros. It might be other things as well. Or would, okay, so let's do like, it could be FFI. But we have two types of FFI. We have scheme and we have C. Okay, so here's what we do. Scheme FFI. Great. And we put this here, and here we do like, let's see, IO maybe. Wait, there's also, that's interesting. I didn't think about that. Actually, no, what? This is inlined. Okay, no, so this is good. IO utilities. Yeah, let's go with that. That's fine. IO utilities. We can refactor this later on. Okay, so we have this scheme FFI in here. What we need now is here, because right now I think if I build this, yeah, scheme utils not. Oh, okay, first of all, we can reorganize this later on. IO utilities, and in here, okay, build. Right, I expected that, because here we need to do this. Scheme FFI. Now it works. Okay, cool. I would love to make like a make file or something that, so that we can run and it will rebuild only when, like, we don't have to manually rebuild every time. There is you can actually do this. You can do depends on, like, no, oh, right, here, depends on, build, I think it's like, whoops, so if you do run now, it builds first, yeah. I wonder if, no, I was thinking about maybe doing like a clear or something, but we can do here actually. There it is, clear crew. There we go. Oh, run. Boo! It defaults to build. Oh, okay. Okay. I'm gonna do this. There we go. Nice. There's probably some people watching this thinking, oh my god, what a rogue. Cool. Okay. Cool. All right, so we have this. Now, the question is, can we do this? Do Huey, Dewey, Louie. Huey, Dewey, Louie. Hey, nice. Okay. Can we do this? I think we can. Okay, cool. And if I do this, this is wrong. Yeah, it's unit. Correct. Awesome. All right. Now, I am curious. What happens? How does this look? So here's the core. Let's look at this first. Okay, here's main. And if you're thinking like, oh my god, so much extra fluff, this is just compile time. This is compile time instrumentation. This is this has no runtime cost. Okay, and this is source location, like meta. So you can do cool things like you can implement like assert, and if it fails, it reports source location. I think we'll implement something like that just because we can. Okay, let's see here. Okay, so this is, yeah, so this is, what's happening here? App, applying, here's something. Hello is applied here, and the hue is applied on hello. And referencing discard, and this is applied on discard. That's interesting. So that's interesting. This is, so here's what we're going to do. We're going to do, we're going to, do I have, no, I want that. I want optimize. Settings. To do, doing, done, bug. Okay, here's what we're gonna do. Optimize. I think this is, I don't know if we have, let's do this, clock. Cool. And let's, oh, it's pink. What the hell? Can't be pink. Are you nuts? This should be proper red. There you go. Harsh red. Oops. There we go. Okay, cool. And this should be like, oh, this should be more like, yeah. Nice. There we go. Okay. Nice. Awesome. Statically remove discard. Yeah, because I don't think yeah, we're gonna look into that, because that's where were we? Okay, get rid of you. That's something we're gonna look into. Where are you? Here. Yeah, because it's like you're applying this to this. Because I'm pretty sure, like, we can actually look into it, but I think if we look here, if I remove this, I don't think this is going to work. Yeah, exactly. This is not going to work anymore. Okay, so we need this. Okay, that's worth looking into. I just want to add another to-do, by the way. To-do, assert. Oh, also, by the way, this is really nice. We want that too. We want to be able to have like a, we want to be able to print out without worrying about, like, without show instance, just use the default scheme and write out the source location. That can be very useful to have. If anything is, it's cool to have. Okay.